Hi, today we will understand the benefits of the queue. The data structure subject consists of many structures, linked list, single linked list, tags, queues, and students find them a bit critical to understand. Sometimes they ask me desperately, sir, what is the benefit of using queue in real life? Or in fact, what is the benefit of the entire data subject, right? Actually, let me tell you, all the system programs, compilers, whatever the software packages that we see around us, internally they use these data structures, stacks, queues and everything. For example, let us talk about our operating system. Whenever you run any program, basically your program is divided into several processes, small processes, right? When your process needs CPU time, operating system puts them into a queue. Basically, what is a queue? Queue is a FIFO structure, first in, first out. You must have seen the queues in front of railway reservation windows or air reservation windows, whatever. See, for example, this is a queue. The first element is added here. The next element will be added at the back. The third element will be added again at the back. So, the additions in the queue are done at the back. All additions will be done at the back. The first person in the queue will be given the reservation first. After that, the second person is given the reservation. So in simple words, we can say that in case of queue, the additions in the queue are done at the rear end. Everything is added at the end and the deletions are done from the front. That is first come, first served, right? So I was saying that in case of operating system, there are two types of queues, ready queue and wait queue. In ready queue, you will find all the processes that needs the CPU time. That is, they are ready to be executed. So depending upon the algorithm that the operating system is using, CPU will take one process from the ready queue, will either execute it completely and will pick up the next process from the ready queue, or it will dedicate some time slice to this process, and after that, after dedicating certain time, that process will be passed to wait queue to be given the time later. It might be that way that the CPU is giving some specific time slice to every process one by one, and after the expiry of every time slice, that process is shifted to wait queue so that it will work in a round robin fashion. Or the CPU might execute this process completely, then it will discard this process, will take out another process, whatever. But while executing a process, it might happen that this process requires IO operation, that is input-output operation. In that case, while the user is entering some data which is required by the CPU to process, the CPU won't sit idle. It will pick up the next process in the queue, right? So what it will do, it will place this process into the wait queue and will switch context to the next process. So these are the sort of the queues that the operating system makes internally. The moment IO operations of this process, which is waiting in the wait queue, is over, the operating system will put it back to the ready queue, and after executing these processes, the time will be given to this. Let me tell you that CPU works in nanoseconds, right? And the IO operation done by the user might be in seconds or in milliseconds if it is very fast. So that means the CPU can execute many processes in the time that the user is entering some data. So that you can see in the queue that deletions are done from the front and the additions are done at the back. And if you want to understand how the queue is actually implemented, you can visit the link provided over here. You will understand this whole program and you will understand step by step how the queue is really implemented with the help of arrays. Thanks for watching the video. Have a nice day.